Hello everyone, and welcome to my channel. Today, I'll be diving back into coding by adding tree, bush, and grass details onto the terrain using procedural planting. Let's quickly jump into coding by adding the tree and bush planter script to the script folder. I'm swiftly deleting the default methods. I'll add them back if needed. First, I'm obtaining a list of terrains since I'll be placing trees on the terrain. To determine which trees to plant, I'm also obtaining the tree prefabs. For controlled tree planting, I want a density control similar to what's in terrain tools, and to add more natural distribution, I'll introduce some randomness using Perlin noise. Now I can add the start method again. I start by adding tree prototypes. I'm doing this within a separate method for better organization. I create an array of tree prototypes equal to the number of tree prefabs and loop through to add their game objects to this array. Then I return this created prototype array from the method. Since each terrain has its own prototypes, I iterate through all terrains and add these prototypes to their terrain datas. Considering that the terrains we create might be quite large, I'm adjusting the tree distance to be shown on the terrain here to avoid potential performance issues later on. Since I'll be connecting all scripts together and initiating world creation in the future, I won't have the chance to make corrections directly on the terrain. We can start planting trees using the plant trees and bushes on terrain method. While taking tree prefabs, I'll also take bush prefabs and plant them together. I don't want to deal with optimization later on since I'll be iterating through the terrain with nested loops for planting. Within the Create Terrain Prototypes method, I'll also include adding bush models. However, to differentiate between trees and bushes and access their respective prefabs, I'll use a variable to store the index of the last tree prototype and retrieve tree or bush prefabs by accessing prototypes up to this index. I also add bush prefabs to the tree prototypes and finish my work with this method. Our terrain data now knows the prefabs we added to our script and can place them on the terrain. Now it's time to plant these prototypes onto the terrain. The tree instance gives us information about what kind of vegetation is at which coordinates on the terrain. First, I create a list to generate this data. To traverse the entire surface of the terrain, I use a nested loop. The first thing I want to check is the slope at the selected coordinates. If the slope exceeds the angle I defined, I can't plant anything here because the terrain painter has painted the terrain with a rock texture beyond a certain slope. I don't want a tree to appear on top of a rock. The getSteepness method gives us information about the slope of the terrain at the specified coordinates. If the slope is less than what I defined, I can plant vegetation. I make the areas where vegetation can be planted slightly more random using Perlin noise. I obtain different coordinates with different noise scales for trees and bushes. If the value from Perlin noise is less than the density I specified, I can plant a tree here. I want trees to not be planted continuously on the same x or z coordinate, so I use offsets on the x and z axes. If I didn't use these offsets, the trees would be planted in a regular pattern, resembling a planted orchard with tractor lanes between them. Now onto the next check. Certain parts of the terrain are underwater, so I shouldn't plant trees there. The terrain sample height method gives us the height value of a coordinate on the terrain. It's important to note that we also need to send the terrain's position. Otherwise, we might not get the correct value. If the height we found is above sea level, we can now plant our tree. As mentioned before, we keep track of planted trees using the tree instance class. After providing information about the tree's position, which prototype prefab it will use, its width, height, and rotation, we can return this object. The returned object is then added to our list ready to be planted on the terrain. After the noise control for bushes, we will perform similar operations to tree processes and move them here. The only thing I need to change here is which prototypes are showing bushes. Now, by sending the trees ready to be planted to the terrain data and using the flush method, we update the terrain data to plant the trees. I will use Unity's Terrain Sample Asset package for tree models. I import the Terrain Sample Asset package into my project from the Package Manager. I can add the tree and grass planter script to the terrain object and assign the prefabs required by the script. Of course, I don't expect the code I've written to run without errors. When creating prototypes, since I looped through the tree prototypes instead of tree prefabs, I'm trying to create prototypes for non-existent values. Since I assigned the last tree index to the max tree prototype index, I needed to add +1 to the max tree prototype index to find the first bush prototype. It looks a bit odd, but it seems like I've managed to plant trees on the terrain. Now it's time to change some values to achieve a more natural look. We can widen the areas where trees can be planted by increasing the noise scales. This way, trees will appear further apart and more abundant. The density value also specifies how many trees and bushes we want. It would have looked nicer if we had some grass on the terrain. Let's add some grass to the terrain then. I'll add my grass within the Add Grass to Terrain method. But first, I'm defining the grass models, and I need to register them as prototypes for the terrain to recognize these objects. The grass models I want to add will be found in the Detail Prefabs list. I want the grass to be customizable with density and noise scale. I specify that the grass will be mesh objects, not billboards, using the usePrototypeMesh property. They will be instanced by the GPU and directly controlled by the density scale setting in the terrain settings. The density property allows us to choose different densities for different types of grass, but I want them all to have the same density. If we're using mesh objects for grass, the render mode must be set to vertex lit. Otherwise, the added meshes won't be detected or rendered by Unity. Now that I've created the prototypes, I can assign them to terraindata.detailPrototypes to allow the terrain to recognize these objects. Here, unlike tree planting, we'll use a detail map. We can't specify on the detail map which coordinates will have which grass. The detail map is a two-dimensional integer array, so it only holds information about the grass density at each point. There's no place to specify which prototype will be used. Instead, there's a layer system, where each detail map layer holds information about a different detail prototype. Therefore, I'll first create a loop for each of my grass prototypes to create a different layer for each. I'll create an integer array the size of the detail map and add grass density information to this map. Similar to the tree planting process, I'm again acquiring slope and height information. Because there won't be grass on snowy mountains here as a difference, I don't want grass details to form in snowy regions. I'm changing the private variables marked as serialize field to public because I'll set these values from the map creation screen later, meaning I won't be able to manually intervene. To achieve a different noise scale for each layer, I shift the noise pattern by I times 100 for each layer. If the noise value is less than the specified density, we can proceed with planting the grass. Note, when assigning, we're assigning ZAX instead of XZ. Otherwise, our created detail map appears flipped, causing grass to appear in unwanted areas on the terrain and not where it should be visible. I set the density information by multiplying the noise value by 255 so that there isn't a constant planting density, resulting in smoother transitions. Another note, I'm not sure why I chose the value 255. I found this value through trial and error. Since we're talking about a detail map, I thought this value could take the maximum value of a color channel, hence I chose 255. If you ask why we created an integer array instead of a byte array if the maximum value is 255, I don't know the answer. I couldn't find it even in Unity forums. We set each detail layer we created to the terrain data with the layer number. Then we flush the terrain. Now we can switch back to Unity and add our grass prefabs to the script. However, it seems like the grass is not appearing. When I check the terrain details, I notice errors in prototype assignments. Unity warns that it can't find a suitable prototype. In the create detail method, I need to add the game objects I retrieved from the prefab as prototypes. Currently, in the scene view, there's some greenery on the terrain. However, no trees or vegetation are visible in the game screen. The reason for this is that I've only given one terrain to the script for testing. I add the other terrains to the script and run it. When I check the stats, even though there isn't a proper grass density, it shows 226 mtries, resulting in an FPS of 3.4.
Brother, what's that? What's that, brother?
Upon inspecting from the profilers, it's evident that there's a significant load on rendering. When I examine exactly where the issue lies using the frame debugger, it appears that even the grass that's not visible on the screen is included in the rendering calculations. We can determine how much of the detail map will be loaded through the detail resolution per patch parameter. Since my terrains had a detail resolution of 512, the detail map with a resolution of 512 was trying to load entirely, which was causing performance issues. I updated the detail resolution per patch parameter by setting the second parameter in the setDetailResolution method to 16. Unfortunately, I spent 3 days without knowing this information, and I even wrote my own detail mesh loader, but I couldn't achieve the desired performance. Then I realized that there was such a simple solution. I'm changing the detail scatter mode to instance count mode because I want a denser grass area. Since there is no LOD structure on the tree prototypes and they don't use the shaders specified by Unity, they appeared white at far distances. Therefore, I'm increasing the tree crossfade length value to its maximum of 200. Since the tree shaders have fade-out parameters, this control is unnecessary. Thank you for watching my video until the end. I hope you found useful information. You can share your suggestions and opinions in the comments. Since I don't have any pre-recorded videos in stock, I make developments within that week. It's challenging to create weekly content because I'm also working on another game project. Therefore, I haven't decided yet on the development for next week, but you can follow my channel to stay informed about updates.